Hello you lovely people, it's Alex here, and I'm going to talk you through assignment 2 and exactly what you should have done to analyse the map that we had that had a fold in some sedimentary units. Before I start with that though, I'll just point out that this is the first time I've done any kind of video recording like this, so there might be one or two little problems along the way with it. Just bear with me and we'll get there. So here's our map. We can see we've got 3 units on here: the Duke Formation, the Nicholas Formation and the Trinity Formation. We've got a north arrow, we've got a scale bar, so we've got everything we need. Now, as we learned in the first mapping lab, the first thing we have to do with this map is to look for places where our contacts between units cross over our topographic contours, because they're the places that we have the most information on this map. So for the Duke Formation, we have these points along here, and for the Nicholas Formation, we have these points along here. Now, notice how I've coloured these. All of the ones for the Duke Formation, which is blue, have been coloured in blue. And then all the ones for the Nicholas Formation, which is green, have been coloured in green. You could, if you'd wanted to, equally coloured all of these yellow for the Trinity Formation down here, and then all of these green for the Nicholas Formation. It doesn't matter which way around you do this, as long as you pick a style and stick to it within the map. So I couldn't make these ones blue and then these ones yellow, because that's not consistent. But I could do blue and green, or I could do yellow and green. Now, either of those would be absolutely fine. So the next thing I do, as I hope you'll be able to tell me, is to add on structure contours for these. So we join up points which are for the same unit and have the same height on their topographic contours. So for instance, these 2 points are both Duke Formation and they're both 170 meters high. So we draw a straight line through them. Same with these for the 160s, 150s. And the thing that we saw here, which I pointed out in the walkthrough, was that a lot of these don't look like they make straight lines. So if we look at the 160, is that? No, it's 150 meter high points for our Duke Formation contact. We get 1, 2, 3, 4, 5. They don't make one straight line. We have to put 2 lines with a bend in between them in order to fit all of those points. And if we follow that trend across the whole map, then we get this line appears here where all of these lines bend. Now we can't put it in for all of them because some of these don't have a point on the eastern side of the map, but we have to do our best to estimate where they are. A few of these is enough to work out we've got a fold going on, and then that just tells us that we shouldn't draw these ones any further than this line here, which is where our fold is. And just like we did in the first lab, even though we've only got 1 point for some of these, we know from the way that these rocks work that it ought to be parallel. This line needs to be parallel to this line, and all of these lines which are blue need to be equally spaced, so we can actually draw it in. And we could, if we wanted to, even extrapolate these ones over here, because we know that they have to be parallel to the ones over here. We haven't actually done that because we don't need to, but in principle we could. Another thing to notice here is the way I've coloured things. A lot of people seem to be having a bit of trouble getting their heads round what I meant when I said to colour code your structure contours. So the way I've done it here is the correct way. So all of these blue structure contours, all of them have been drawn for this contact with the Duke Formation. So the reason I coloured these dots blue was because they were all next to the blue unit, and then I've coloured all of the structure contours blue as well, because they are all for this blue unit. And then all the ones for the green unit down here, everything is in green. So that's the way you ought to do it with your own, because that way when things start getting a bit messy, which they might do in the future, it's a lot easier to keep track of what's going on. This is a nice example, and it's not really necessary here to colour code things because it's being neat, but it's possible on some other maps that some of these blue lines might end up, for instance, in between all of the green lines. And then if you've got 2 separate sets of contours for 2 different sets of planes, all mixed up with one another, unless you've color-coded them in a really sensible, intuitive way, it's really easy to lose track of what's going on. Now, because of the way this mapping program works, I've had to label my structure contours along the line. I would suggest for you, it's easier to do it off the edge of the map, because you've got a nice big piece of white space there. I just couldn't get my computer to do it that way, I'm afraid. So we've labelled all of them, labelled them in the colour that the line is. That's a nice thing to do. It's not essential, but it's nice. And so we have this nice, neat set of structure contours going all across the map, showing me what's going on. So the next thing to do, which I showed you, is to draw on where our fold is. We can basically join up all of these points where our structure contours bend, and that gives us the fold axis, which we label somewhere as fold axis. Here it is. So that tells us that this is where in space, this is the place in space that our rock units are being bent in half, somewhere. And in this example, that fold axis goes straight down into the ground. That's not always true for folds. Some of them have very strange shapes, but it will always be true for the ones that we do in this course. Whenever I give you one to do, it will always be true that your fold axis, once you've found it, just goes straight down into the ground vertically. So all that's left to do with this before we move on to a cross section, which is the really important part, is to work out our strike and our dip. So for our strike, we need to draw on these little symbols. And the bar part of this goes parallel to your structure contours. That's your strike line. And then the bit that's coming off it here is the dip symbol, which points in the direction that these things are going down. So if we look at one of these sets of contours, if our 170 meter contour for this plane is here, and then 160 is there, 150 is there, 140 is there, that tells us that this plane is dipping that way. It's dipping off towards the north of the page. And the same is happening over here. We've got dip to the north. Although they're not quite parallel to each other, and they do kind of dip towards each other a little bit, which is because of the fold. So we've got our strike symbols on here. And we measure the strike straight off the map by measuring from north round to the strike symbol. But if we remember carefully, there's a convention to how we do this, and we have to measure round to the correct part of the symbol, which is this side of it. That's just how it goes. So I've got some slightly different symbols here where I've put a little black dot on there to show you which bit of the symbol to measure round to. If we turn the symbols round the other way, if everything was dipping to the south, we'd be measuring round to this side. But because everything's dipping north, we've got to measure all the way around here. And that gives us our strike numbers. Now, what they actually are is somewhere around 240 degrees on this side, and somewhere around 290 degrees on this side. Exactly how much you get depends on how well you've drawn your lines, and exactly how carefully everything's been done, but it's somewhere around 240 and 290. Now, the other numbers that have appeared on there now are the dip angles, which we ought to be able to work out because we measure the difference between two of our structure contours to give us the horizontal distance between them, and then we use the numbers on them to give us the vertical distance between them, and we can do some trigonometry to work out what the dip angle is. I'm not going to go through that today on this video. If you're still having a bit of trouble with that, get some examples from me or ask me about it, or check that you can do that, because it's an important skill. So we've got all of our structure contours drawn in here, we've got a fold axis drawn on, we've got some strike and dip symbols, and we're ready to move on to doing a profile, a topographic cross-section and a geological cross-section to show people what's going on if we look at it from the side on, which is often a better way of showing things. Now, the feature that we want to show on this map, and the thing we're showing people if they look at our map, is this fold. So if we draw a cross-section, it should be as close as we can get it to being perpendicular to this fold axis, so that we're cutting across the fold. That's going to give people the best impression of what's happening with our rocks. So, if we come and look at our our cross section now, so far all I've drawn myself is a template for it. So I've got a box, I've got some elevations, I've gone down to about 80 meters, which seemed like a sensible depth to go down to. You want to go down a bit further than your elevation does because you want to show what the rocks are doing. But in this case it didn't seem to make sense to go all the way down to 0 because our elevations are between about this kind of range here, between 170 and 120. So we want to go down just a bit further than that to show the geology. I've got my line here from A to A dash, and you can see I've copied across the scale bar from the map. Because I've copied this line straight from the map, I'm allowed to also copy the scale bar to give people a scale, and then this axis has been labelled with the elevations, and I've given people the units of meters. So in order to construct this thing, the first thing I need to do is go along my line and mark on just places where this line crosses over a contour. So those are places where I know about the height of my landscape. And then if I come back to here, I don't know where it's gone. Where's it gone? Well, I did say there would be some gremlins. So I guess what happened is I went back to the window with my profile in it and everything had zoomed in so I couldn't see what was going on. But we're back now. So we got as far as starting to draw our cross-section, and we said we needed to put on points on this profile where our profile line crossed topographic contours on the landscape, which if we draw a nice line in between them gives us basically what our landscape looks like across here. Yours can be a bit smoother than that. I couldn't achieve a completely smooth line on the computer, but you should bear in mind that normally, unless you're in a mountainous region, landscapes tend to be fairly smooth and they don't tend to be too pointy. So we've got our landscape profile. So the next thing to do is go back to our map again and mark on places where this profile line that we've drawn crosses geological features. So we've done the landscape features, we need to do geology now. And in this case it crosses a contact here, and it crosses the same contact over here. So there's 2 points. It crosses a different contact down here, and it crosses the fold around here. So if we come back to our cross section, we can mark those points on as well. We've got these 2 points here, which is where our profile is going to cross where the blue unit comes out of the ground. We've got a point down here for that green contact, and we've got our fold here. Now we know our fold is going to go straight down into the earth, so we're going to be able to draw it on as a straight vertical line. And we know from looking at our strike and dip of the units on the map that these units are going to dip in towards the fold. If you're not sure about that, make sure you go back to the map and work it out. That this dip symbol here, if we were to follow it a long way, it would eventually bump into the fold somewhere off to the north. And so would this one. It would eventually hit that fold line. It might take it a while, but it would get there at some point. It would hit the fold. And this, if we add those two things together, we get a V pattern for our beds. And if we're looking at them from the side on along this fold, we're going to get a V pattern for them. That means that if we come back to our cross section, this bed is going to dip this way towards the fold here. Once it hits our fold line, it's going to inflect, it's going to bend the other way, and it's going to come back out the ground here. And that all ends up looking a bit like this. So as our fold axis, as close as we can get it to vertical, and we've got a V pattern here for this contact. Now, on any one side of the fold, it still has to be a straight line, because it's still describing this nice flat plane to us. But just like the plane, which is our contact, bends when it gets to the fold, so does our line on the cross section, because it's really showing us the same thing. And what that's really telling us is it's the same place where our structure contours on the map bent and went off in a different direction. Now we've only got one point on this cross section for where we need to draw our green line, but we can start now using some of our principles of stratigraphy, some of the things we know about how sedimentary rocks work, to help us draw this line in. So we know that when these rocks were laid down, when they were deposited, they would have been parallel to each other, and they would have been in nice flat layers. Which means that this line has to be parallel to this line, because nothing has happened that's going to change that being the case. They would have been parallel when the rocks were deposited, and they'll still be parallel now. So we can actually draw this line going down into the ground. And because we know that this rock unit here, which if I remember rightly is the Nicholas Formation, which we've got in here, we know as well that that should be the same thickness everywhere, because that's another of our assumptions that we make for sedimentary rocks. They should be the same thickness wherever they are, which means that the distance between this line and this line here, if we measure it at a perpendicular angle, which tells us how thick this rock unit is, that should be the same as the thickness of the rock unit over here. So even though we don't have a point to draw it on, we can estimate whereabouts this line should be on this side as well, because this thickness should be about the same as this thickness. However, because we don't actually have a point to mark it, we're going to draw it as a dashed line, which is code for something that we have inferred from what we know. We don't actually have a point on our landscape, which would be off to the east somewhere, to draw this line on solidly, but we can estimate that it should be around here somewhere. In fact, looking at it now, it probably needs to be more like here to be the right thickness. Now, just a quick note about the angles that we've got on here. It shouldn't take much to work out that I've really exaggerated my elevation in this case. That if we look at our horizontal axis, this is 200 meters, but the same distance on the other axis is more like 60 meters, 50 to 60 meters. So I've got a big exaggeration here. Now that means that I can't just copy my angles across from the map onto the cross section. I can't just measure a 22-degree angle on here and draw it on. My angles are going to be steeper than that because I've exaggerated it. Now that's okay, that's perfectly allowed, because I want to show with this cross section what the beds are doing. And if they were dipping like this, it would be harder to show, and it would be less obvious what's going on. So this is a case where it's okay that I have exaggerated my scale. All that means is that I've got to just estimate where I think these angles are going to be. I know it can't be this shallow because otherwise it would end up coming out of the ground. And I know also that this line, if I carry it on, isn't allowed to cut through this bit of hill. So if I'd made it shallower like this and come out here, then that line would end up going through this bit of hill here, which wouldn't make sense, because if we find that hill on my cross section, I don't see the blue unit there. It's a bit further down. So you can put the angles really wherever you like. Now, because we've got quite shallow dips, they're not going to go down like this, but put them somewhere sensible. Somewhere like this looks good to me. And then all the others you can work out like that, because they'll just be the same. Okay, so I've got my contacts on, I've got my fold axis on. The only thing that's left to do is put some colour on it, and colour these units exactly the same as they are on the map. Add some labels to them so people know what they're looking at, and you have one finished and lovely geological cross section. So make sure that you understand everything we've done in this video. If there's anything you didn't get, anything that still doesn't make sense about this, feel free to talk to me whenever you like, and I will be setting some practices that you can do, some other maps which are maybe easier, maybe harder than this one, to give you a bit of practice with it. And as we go forward, there'll be plenty more of these things to get your feet wet with before we have anything serious to look at. So I hope this has been helpful for you. I'm sure if this goes down well, there will be more of these in the future, and hopefully they'll work a bit better next time. So that's all for now. I will see you next time.